Let us solve a question on game theory regarding iterated elimination of dominated strategies. The question is, in a two-player game, player 1 can choose either M or N as strategies. Player 2 can choose either X, Y or Z as strategies. The payoff matrix is as follows. Okay, we have player 1 and player 2. The strategy profile for player 1 is M and N, and for player 2 he has three strategies X, Y and Z. Okay, red color elements in each cell denote the payoff for player 1, and blue, rather this is green color elements denote the payoff for player 2nd. Okay, we need to find out the strategy profile that survives iterated elimination of strictly dominated strategies. By iterated elimination of strictly dominated strategies, what is meant by this? By IESDS, what we mean, it is a technique for solving games that involve iteratively removing the dominated strategies. Okay, and I will explain here. Let us first explain the dominance here. What is meant by dominance? Okay, let us take simple example. Let us say we have a person or player. He has two strategies R and S. Okay, strategy R gives him a 5 and 6 as payoff. Okay, compared with another player. I am not writing the another player's payoff here, but for the sake of simplicity I am saying we have player 1. He has two strategies R and S. R has the payoff of 5 and 6, and S has a payoff of 2 and 1. Okay, here you can see the strategy R, playing strategy R is always better than playing strategy S, because R is better, 5 is better than 2 and 6 is better than 1. So in this case what we call R is strictly dominant strategy. If R is strictly dominant strategy, that means this S is strictly dominated strategy. Okay, so not to get confused, dominated means it is less preferred here. Okay, compared to dominant. Okay, if R is dominant, strictly dominant strategy, that means S is strictly dominated strategy. Okay, so it was necessary to explain the dominance here. Okay, now we need to solve this question by eliminating any strictly dominated strategy, and we need to find out whether we have the strictly dominated strategies here or not. Okay, so let's take the perspective from player 1, and I'm asking a question, a simple question here. Does player 1, okay, always choose M? Okay, if yes, then we say M is strictly dominant strategy. Okay, by dominance what we mean, I can also explain it in this way, that dominance occur when one strategy is better than another strategy for one player, no matter how the opponent player plays. Okay, the question I am asking to myself is, does player 1 always choose M? If yes, then we say M is dominant strategy, and it also implies then if M is dominant strategy, that means N is dominated strategy. Okay, I have explained to you about the dominant and dominated here. Okay, if no, then we say M is not a dominant strategy. And let us see here. So what happens if player X, and I am asking the question, does player 1 always choose M? Let us see. So if player X, sorry for the mistake, if player 2 chooses X as strategy, what will player 1 choose? Obviously he will choose 3 compared to 0. That means he will play M compared to N, because M gives him 3 payoff, N gives him 0 payoff. So he will play, okay, no problem up to this. But what happens when player 2 chooses Y? Here you can see, so when player 2 was choosing X, player 1 was choosing M. So that was right. Now when player 2 chooses Y, does player 1 again chooses M? Let me repeat. Okay, does player 1 choose M again when player 2 chooses Y? Let us see. When player 2 chooses Y, player 1 will choose to play N, because N gives him greater payoff. That is, N gives him 1 payoff, but M gives him 0 payoff. And here you can see he changes his strategy. He is not always playing M strategy regardless what player 2 is playing. So can we say in this case that our answer is no? Okay, so does player 1 always choose M? No. Okay, and by the same logic, does player 1 always choose N? Let us see. If player 2 chooses X, player 1 will choose to play M. Okay, in the first place it gets vanished. It is not choosing N always. So can we say, and if I write here, can I write for player 1 neither M nor N is strictly strictly dominated strategy. Okay, let's take this question from the perspective of player 2. Okay, let me first sort them up. So I am asking the question, let us see what happens for player 2 now. Does player 2 always choose a specific strategy compared to other strategy? Okay, let's compare here two strategies. I am comparing strategy X and strategy Z. Okay, and here I ask a question, does player 2 always choose Z? Okay, I am comparing strategy Z with strategy X. Let us leave this strategy Y aside for the moment. Does player 2 always choose Z? Okay, if yes, we say it is strictly dominant strategy. That implies compared to x. Okay, that means x is strictly dominant, sorry, dominated strategy. If no, we know that then it's not the case that S is strictly dominant strategy. Now let us see uh, uh, what happens when player 1 chooses M. We are comparing strategy X with strategy Z. When player 1 chooses strategy M, player 2 will player 2 will choose to play strategy Z because Z gives him 2 payoff, X gives him 1 payoff. Since 2 is greater than 1, so he will choose 2. Okay, so correctly, when player 1 chooses M, player 2 chooses Z. Now what happens when player 1 chooses N? What happens here? Does player 2 always choose Z here again? Let us see. So when player 1 chooses N, player 2, you can see we have to compare these two things. Again, for player 2, it is better to play Z because Z gives him 1 payoff, X gives him 0 payoff. So in this case, we can say that Z is strictly dominant strategy, or we say that X is dominated by Z, or in other words, we say X is strictly dominated strategy. Okay, and let's write it here. So for player 2, okay, for player 2, and here we can see X is strictly dominated strategy, or we say playing X is strictly dominated by Z. Okay, so this iterated elimination of strictly dominated strategy means we have to then eliminate the strictly dominated strategy. Okay, let's write it here, dominated strategy. Okay, now we know that player 2 being rational, okay, we assume in this case, okay, in iterated elimination of strictly dominated strategies, it is assumed that both the players are rational and each player knows that the rest of the players are also rational. Okay, now here if player 1 knows that player 2 is rational, then player 1 can eliminate X from the player 2 strategy space. Okay, that means we can remove this, this column from this, because as we have seen, X is strictly dominated strategy. Okay, now what will be our table now? Let us again form the same table. Okay, so we have player 1. Player 1 has again 2 options, M and N, and we have player 2. He has this time only 2 options left, that is playing Y or Z. And here we have 0 1, we have 0 1 and -1 5, -1 and 0.5. These are the payoffs for player 1. And for Y we have 0 3, 0 3 and 2 1. Okay, same process we apply here. Our endeavor is to remove iteratively the strictly dominated strategies. Okay, I will not explain here, it will get now lengthy. Again, let us take player 1 into consideration. Does player 1 always choose M here? Whatever player 2 chooses, let us see. So the question is, does player 1 always choose M? Let us see. So if player 2 chooses Y, player 1 can choose either 0 or 1. So he will always... Okay, let me see if I have correctly drawn it here. So player 1 will choose... Okay, I am getting confused. The question is, does player 1 choose M? Now let us see. If player 2 plays Y, player 1 will choose N. Okay, so M cannot be a dominant strategy right away. Let us see, does player 1 always choose N? Let us see here. So when player 2 plays Y, player 1 will play N because 1 is greater than 0. Does here also this happen? When player 2 plays Z, does player 2 again chooses N? Yes, obviously 0.5 is greater than -1. So here we can see that for player 1, M is dominated. Rather, M is strictly dominated strategy. And it is another meaning is that N is dominant strategy. Our endeavor is to, delete or eliminate the strictly dominated strategy. Let me explain it again. The question is, does player 1 always play N, whatever player 2 plays, whether Y or Z? Here we have seen, if player 2 chooses Y, player 1 will always choose N. If player 2 chooses Z, player 1 will always choose N. So we say that M is dominated by N. That means M is strictly dominated strategy. Okay. So in this case, what will we do? We will, delete this row. Okay. So our endeavor is to eliminate the strictly dominated strategies here. So what will be our next table? Next table will be then we are left with. So इस हिसाब से मेरा कितना हुआ? Let us see. So we have Y and Z. Y and Z are there, and M is being taken away. Okay, and let it be. So we have N strategy left for player 1, and for player 2 we have Y and Z. The payoffs are again, okay, let me use the proper color here. I know it's getting lengthy, but I just want to make sure that I am pretty much more clear to you. Okay, so we are left with N, and let's denote N by this color, Y and Z with Y, Z. So we are left with 1 and 0.5. For this we are left with 3 and 1. Now here player 1 has only one strategy to play N. Okay, what about player 2? So here we can see player 1 plays N. For player 2, Y is better than, rather Y is strictly dominated here or not? So for player 1 has only one strategy N. Okay, what about when player 1 plays N? Player 2 will compare the payoff between 3 and 1. Obviously playing Y gives him more payoff than playing 1. That means player 2 will, or let's write here, for player 2 Z is strictly dominated strategy. Okay, here you can see, so Z is being dominated by 1, this Y. Okay, so we will remove this very strategy also, this profile also. Now what we are being left with, we are being left with only this very strategy, that is player 2 playing Y and player 1 playing N, and their payoffs are 1 and 3. That means and the strategy profile that survives iterated elimination of strictly dominated strategies is N, Y. Okay, I hope I make myself clear in this video. I know it is a lengthy video here, but I cannot do anything with its length. Okay, I hope I make myself clear in this video. Thank you.